Hazardous substances are a common concern in machining production processes. Machining production involves various activities such as cutting, grinding, milling, and drilling, which can generate hazardous substances in the form of metalworking fluids, oils, solvents, and dust particles. Exposure to these substances can pose significant health risks to workers. Inhalation of airborne contaminants can lead to respiratory issues, including lung damage and occupational asthma. Skin contact with hazardous substances can cause irritation, dermatitis, and even absorption of toxins into the bloodstream. Additionally, some substances used in machining production, such as cutting oils, may contain carcinogens or other chemicals that can have long-term health effects. Understanding the nature of these hazardous substances is crucial for risk assessment and control measures. Employers must identify potential hazards, evaluate the associated risks, and implement appropriate control measures to protect workers' health and safety. Control measures may include engineering controls, such as the use of local exhaust ventilation systems to capture and remove airborne contaminants at the source. Administrative controls involve implementing proper work practices, conducting regular equipment maintenance, and providing adequate training to workers. Personal protective equipment, PPE, such as gloves, goggles, and respirators, can provide additional protection when other control measures are insufficient. Regular monitoring and testing of the work environment are essential to ensure that control measures are effective. Air monitoring, surface sampling, and biological monitoring can be used to assess exposure levels and verify the efficiency of implemented controls. It is important to keep records and documentation to track exposures, evaluate trends, and ensure compliance with regulatory requirements. Training and awareness play a crucial role in ensuring the safety of workers in machining production environments. Providing comprehensive training on the hazards associated with machining processes, as well as the proper use of control measures and personal protective equipment, is essential. Promoting awareness and fostering a safety culture within the workplace can help create a proactive approach to risk management. By understanding hazardous substances in machining production, conducting risk assessments, and implementing appropriate control measures, employers can create a safer working environment, protect the health of their employees, and minimize the potential for accidents and long-term health issues. Risk assessment and control measures are crucial elements in ensuring a safe working environment across various industries. Here are the key reasons why they are of utmost importance. Identify hazards. Risk assessment allows employers to systematically identify and evaluate potential hazards present in the workplace. By understanding the specific risks associated with tasks, processes, or substances, employers can take appropriate measures to mitigate those risks. This proactive approach helps prevent accidents, injuries, and occupational illnesses. Protect workers' health. Risk assessments help employers assess the potential health effects of workplace hazards on employees. Identifying and controlling exposure to hazardous substances, physical hazards, ergonomic risks, or psychosocial stressors can significantly reduce the likelihood of work-related illnesses and chronic health conditions. It ensures that workers are not exposed to substances or conditions that could harm their well-being. Legal compliance. Conducting risk assessments and implementing control measures is often a legal requirement in many jurisdictions. Occupational health and safety regulations often mandate employers to assess risks, control hazards, and provide a safe working environment for employees. Compliance with these regulations helps organizations avoid penalties, legal issues, and reputational damage. Prevent accidents and injuries. Risk assessment enables the identification of potential sources of accidents and injuries. By implementing control measures to eliminate or reduce those risks, employers can create safer work environments. This includes measures such as installing safety guards, implementing proper machine guarding, providing personal protective equipment, PPE, and establishing clear safety procedures. By minimizing hazards, the likelihood of accidents, injuries, and near misses is significantly reduced. Enhance productivity. A safe working environment has a direct impact on productivity. When employees feel safe and secure in their work environment, they are more likely to perform efficiently and effectively. Effective control measures can help eliminate disruptions caused by accidents or injuries, reduce absenteeism, and improve overall employee morale and satisfaction. Cost savings. Investing in risk assessment and control measures can lead to significant cost savings in the long run. By preventing accidents, injuries, and occupational illnesses, organizations can avoid medical expenses, workers' compensation claims, legal costs, and the costs associated with downtime and production disruptions. Implementing effective control measures also helps minimize property damage and potential liability. Continuous improvement. Risk assessment is not a one-time activity. It is an ongoing process that encourages organizations to review and improve their safety practices regularly. By regularly assessing risks, organizations can identify emerging hazards, implement new control measures, and adapt to changes in the workplace. This continuous improvement mindset fosters a culture of safety and ensures that safety practices remain up to date. Hazardous substances commonly found in machining production include metalworking fluids. Metalworking fluids are used in machining operations to lubricate and cool the cutting tools and workpieces. These fluids can include various chemicals such as oils, emulsions, or synthetic fluids. Some common hazardous substances found in metalworking fluids include: example, cutting oils such as mineral oils or chlorinated oils can contain harmful additives, including biocides, anti-wear agents, or extreme pressure additives. Oils. Various types of oils are used in machining processes for lubrication or cooling purposes. These oils may contain hazardous substances, including: example, hydraulic oils such as mineral oils or synthetic oils can contain additives or components that are harmful to human health or the environment. Solvents. Solvents are used for cleaning parts, degreasing, or removing contaminants in machining operations. Solvents can pose health risks due to their chemical properties and volatility. Examples of hazardous solvents include: example, trichloroethylene, a commonly used solvent, can have toxic effects on the central nervous system and is a potential carcinogen. Dust particles. Machining processes generate dust particles that can contain hazardous substances such as metal or composite dust. These particles can be inhaled or come into contact with the skin, leading to health issues. Examples of hazardous dust particles include: example, fine metal particles, such as those generated from grinding or milling operations, can contain toxic metals like chromium, nickel, or lead, which pose health risks if inhaled or absorbed into the body. It is important to note that the specific composition and hazards associated with these substances can vary depending on the specific formulations, suppliers, and regulations in different regions or industries. Employers should carefully evaluate the materials and substances used in their machining operations and follow appropriate safety guidelines and regulations to protect workers' health and safety. Exposure to hazardous substances commonly found in machining production can pose several potential health risks to workers. These risks can manifest in various ways, including respiratory problems, skin irritation, and long-term health effects. Here's a breakdown of the potential health risks associated with exposure to these substances. Respiratory problems. Inhalation of airborne contaminants generated during machining production can lead to respiratory issues. Workers may experience respiratory irritation. Exposure to metalworking fluids, oils, solvents, or dust particles can irritate the respiratory system, causing symptoms such as coughing, wheezing, or shortness of breath. Occupational asthma. Prolonged exposure to certain substances, such as metalworking fluids or dust particles, can trigger the development of occupational asthma. This condition is characterized by inflammation and narrowing of the airways, leading to breathing difficulties, chest tightness, and wheezing. Skin irritation. Contact with hazardous substances in machining production can cause skin-related health issues, including dermatitis. Metalworking fluids, oils, and solvents can irritate the skin, leading to dermatitis. Symptoms may include redness, itching, dryness, or the development of rashes or blisters. Chemical burns. Certain substances, especially strong solvents, can cause chemical burns upon contact with the skin. These burns can range from mild irritation to more severe damage, depending on the concentration and duration of exposure. Long-term health effects. Prolonged or repeated exposure to hazardous substances in machining production can have long-term health effects, which may include respiratory diseases. Chronic exposure to airborne contaminants, such as metalworking fluids or dust particles, can contribute to the development of chronic respiratory diseases, including chronic bronchitis or chronic obstructive pulmonary disease, COPD. Skin disorders. Continuous exposure to certain substances may lead to the development of chronic skin conditions, such as contact dermatitis or occupational eczema. Carcinogenic risks. Some substances used in machining production, such as certain metalworking fluids or solvents, may contain carcinogens or chemicals known to be associated with an increased risk of cancer. Prolonged exposure to these substances can contribute to the development of various types of cancer, depending on the specific hazards involved. It is important for employers to implement appropriate control measures, such as engineering controls, administrative controls, and the use of personal protective equipment, PPE, to minimize workers' exposure to these hazardous substances. Regular monitoring, training, and adherence to safety guidelines and regulations are crucial in mitigating the health risks and ensuring a safe working environment for employees. The risk assessment process involves several key steps to systematically identify, evaluate, and control the risks associated with hazardous substances in machining production. Here are the main steps involved in the risk assessment process, along with an example. Hazard identification. The first step is to identify the hazards present in the workplace. This involves recognizing the substances, processes, or conditions that have the potential to cause harm. For example, in a machining production facility, one identified hazard could be the metalworking fluid used for lubrication and cooling. This fluid may contain hazardous additives or substances that pose health risks. Exposure assessment. Once hazards are identified, the next step is to assess the exposure potential of workers to those hazards. This involves determining how workers come into contact with the hazardous substances, the duration and frequency of exposure, and the pathways through which exposure can occur. For example, in the case of metalworking fluids, exposure assessment may involve measuring airborne concentrations of metalworking fluid mist or assessing the contact of workers' skin with the fluid during machining operations. Risk characterization. Risk characterization involves evaluating the likelihood and severity of harm resulting from exposure to the identified hazards. It combines the information from hazard identification and exposure assessment to determine the level of risk. For example, based on the hazard identification and exposure assessment, the risk characterization may indicate that there is a moderate risk of respiratory irritation and dermatitis due to exposure to metalworking fluids. The severity of harm may be determined by considering the concentration of hazardous substances and the duration and frequency of exposure. Risk evaluation. In this step, the assessed risks are compared against established criteria or standards to determine the level of risk acceptability. It involves making judgments regarding whether the identified risks are tolerable or require further risk reduction measures. For example, the evaluated risk may indicate that the identified hazards associated with metalworking fluids exceed the acceptable risk thresholds, necessitating the implementation of additional control measures to reduce exposure and mitigate the risks. Risk control. The final step involves implementing control measures to minimize or eliminate the identified risks. This may include implementing engineering controls, such as local exhaust ventilation systems, providing personal protective equipment, PPE, establishing safe work practices, and providing adequate training to workers. For example, in the case of metalworking fluids, risk control measures may involve installing effective local exhaust ventilation systems to capture and remove mist, ensuring proper storage and handling practices, providing appropriate PPE such as gloves and safety glasses, and conducting regular maintenance of the machinery and fluid systems. By following these key steps in the risk assessment process, employers can identify hazards, assess exposure, characterize risks, and implement control measures to ensure a safe working environment and protect workers' health. It is important to regularly review and update the risk assessment as new hazards are identified or as changes occur in the workplace. Various control measures can be implemented to mitigate the risks associated with hazardous substances in machining production. These measures aim to reduce or eliminate exposure to the hazardous substances and ensure a safe working environment. Here are some examples of control measures. Engineering controls. Local exhaust ventilation. Install and maintain effective local exhaust ventilation systems to capture and remove airborne contaminants at the source, such as fume hoods or extraction systems. Machine guarding. Implement proper machine guarding to prevent contact with moving parts, reduce the risk of injury, and contain any potential release of hazardous substances. Administrative controls. Training and education. Provide comprehensive training and education programs to workers, ensuring they are aware of the hazards associated with the substances used in machining production and are knowledgeable about safe work practices. Work practices and procedures. Establish and enforce safe work practices, including proper handling, storage, and disposal of hazardous substances, as well as regular equipment maintenance. Hazard communication. Implement effective communication systems such as labels, safety data sheets, SDS, and signage to inform workers about the hazards, proper handling procedures, and emergency response protocols. Personal protective equipment, PPE. Gloves. Provide appropriate gloves, such as chemical-resistant gloves, to protect workers' hands from direct contact with hazardous substances. Eye and face protection. Supply safety glasses, goggles, or face shields to shield the eyes and face from potential splashes, airborne particles, or chemical hazards. Respiratory protection. Use suitable respiratory protective equipment, such as respirators, when engineering controls alone cannot sufficiently control exposure to airborne contaminants. Substitution and process modification. Substitution. Consider substituting hazardous substances with less harmful alternatives, such as using less toxic metalworking fluids or solvents, or replacing processes that generate hazardous dust with safer alternatives. Process modification. Modify machining processes or equipment to minimize the generation or release of hazardous substances, for example, by using closed systems or automated machinery to reduce worker exposure. Regular monitoring and testing. Air monitoring. Conduct regular air monitoring to assess the levels of airborne contaminants in the workplace and verify the effectiveness of control measures. Surface sampling. Perform surface sampling to check for the presence of hazardous substances on work surfaces and evaluate the effectiveness of cleaning procedures. Biological monitoring. Implement biological monitoring programs to measure the uptake or presence of hazardous substances in the bodies of exposed workers, providing additional insights into exposure levels. Remember, the specific control measures implemented should be tailored to the hazards and risks identified through the risk assessment process. It is crucial to regularly review and update control measures, as well as provide ongoing training and supervision to ensure their effectiveness and compliance with safety regulations. That's all for today, see you in the next topic.